All right, so we have made it to the end of the semester and we are doing our review. We're going to make this happen. We're going to do well in this final exam because we're going to get this. We got this. All right, so with it, like I told you guys in class, I'm going to go ahead and create these videos for you guys to go through the first 10 questions. And we're going to do this for each class period. So that means we're going to go through all 30 questions. We're going to spend 10 minutes, do a video for each one of these questions here. All right, so first off, starting with question 1, and it's actually a really question, but it says graph f of x equals 2 absolute value x plus 2 minus 3. So if we're going to graph it out, we need to make sure we know what our transformations are. So we know it goes down 3 here, put that 3 in the back. We know this plus 2 goes to the left 2. And we know here we're going to compress it because it is actually greater than 1, sorry. So it's going to compress. So when we do this, we're going to graph it out. We're going to compress it, bring it in. So if it was like this originally, it's going to come in like this. We're going to compress it in. All right, so we're going to go ahead and graph this out now. Make sure you label your graph, because if you just put a dot there, I don't know what that is, and therefore it's going to be marked wrong because I just don't know what you put down. All right, so here we're going to start off with our parent graph. I'm going to do that in green, and then I'm going to do the transform graph in purple. All right, so we know our parent graph is here, absolute value. All right, we say from that origin, that point here at the origin, we're going to go down 1, 2, 3, and we're going to go to the left 2, 1, 2. All right, it does not get bigger, it does not flip, so that means it's going to compress. So with this part, I'm not going to actually go by a specific number, but I'm just going to show that it compressed. Does not mean it gets smaller, as in like it gets smaller this way, but it compresses this way. All right, and that's it, guys. That's all we have to do for number 1. So we moved it down 3 to the left 2, and then we compressed it, made it less wider than this one. All right, so not bad. We got that. All right, number 2. This one asks us to write the equation for the graph, and this is going to require us to actually see the graph. So let's go pull that over a little bit. All right, so here we automatically know, looking at the types of things that we talked about in class already, we know that the parent graph is absolute value. It's a V, so it's an absolute value graph. All right, so with that, as you're moving forward and as you're going into this part, you need to look at the transformations that are happening. So first off, we know that a regular absolute value graph opens up like that. This graph, if you look at it, it's opening down. This one's opening down. So if it's opening down, that means it flipped about the x-axis, which means we have to have a negative in front of the function. Let me change the color. Purple. Ooh, it don't even look like purple now. All right, so here we're going to do it should be g of x. Actually, let's do it in green to match up the color. So g of x. We know it's a negative in front because of that flip that we said right here. And we're going to look at the absolute value portion of it. All right, so looking at this part, again, we know we flipped. So from the parent graph, we know it comes like this, like this. We know it goes, if it flips, it means it's going down this way. All right, but then if you look at it from the origin right here, like we have on our graph, it went up 3. So it went up from here, went up 1, 2, 3. Let's do it. So that went up this way. So it went up 1, 2, 3. And it still flipped down. So that means it went up 3, so it's a positive 3 here. like you said. So it goes up 3, so it's positive 3. So we automatically know on the outside, because remember, outside is the part that goes up or down. That's a plus 3 there. All right. The other part is just trying to see if there's actually like a some type of, well, first off, before we do that, did it move left or right at all here? It went up. Did it go over to the left or to the right? No. So remember, inside it goes left or right. So there's nothing that goes there. So we just leave it as x. It doesn't go left or right. So we don't do anything to the x inside. We don't add anything to it or subtract to it. All right. Then the other part is just looking at the slope. Here, it's going down 1 to the right 1, down 1 to the right 1. So here, really, when it comes to the slopes for these, they don't change. They're the exact same as the original function. So the absolute value function. So since there's no change in the slope, it goes up 3 and it flips. This is going to be our equation that we're looking for. Nice, nice. All right, so then number 3 is the part that people are like, oh my gosh, Mr. Hall, this is so confusing. Oh, it's not confusing, guys. Sorry, number 4, number 3. Let's go ahead and take a look at that one. That's our graphing our piecewise function. Guys, we got this. We can do this. All right, so as you see there on number 3, it gives you 2 functions. And I can't keep drawing these tables too long. They don't need to be this long. So you should better stop right there. All right, so here we have the x's here on the left side. These are x values. Our y values are f of x goes on the right. So for our first table, because we have 2 equations here, 1, 2. So we have 2 tables, 1, 2. So our first table will be x squared for the x squared there. And then our second table will be 2, f of x equals 2 for the equation that's there. All right. So with that being said here, we have to look at our x values that they give us. So they say x is less than negative 1. So we're going to start with negative 1 because remember, we always start with that. And we're going to go till we get down to a certain number. It don't really matter how far we go. We're going to stop at negative 4. We actually could have stopped at negative 3. But here, remember, we start at the negative 1 because the numbers between negative 1 and negative 2, like negative 1.5, has to be accounted for. So if you start at negative 2 and leave off the negative 1 portion, all the numbers between negative 1 and negative 2 pretty much don't exist, which means your graph is inaccurate. It's wrong. So to show that it does not equal negative 1, but it still can account for all the numbers between here, there's a less than sign right here. Since it's a less than sign, that means an open circle at negative 1 for this first table. And then remember, only the endpoints are the ones that can be open or closed circle. Everything else is a closed circle. So that's the endpoint, negative 1. The rest of these are going to be closed circles. All right, so for the second table, x is greater than or equal to negative 1. So we have negative 1, 0, 1, 2. You can go on if you want to. Again, with this part, negative 1 has the equal to sign there. So since it has equal to, we'll close that circle there. Closed circle. That's your endpoint. And then everything else is going to be closed also to match up with it. All right, cool. We're doing good. All right, so coming back to this first table, to find these values, we do negative 1 squared. So negative 1 times negative 1 is positive 1. Negative 2 squared, negative 2 times negative 2 is 4. And then 9, and then 16. So negative 3 times negative 3, negative 4 times negative 4. When it comes to the second one here, second table, it is a constant function, which means it does not change. It does not go up or down. It stays the same no matter where you are in this. Just like people. Constant people are stay the same. So no matter where you are in life, you're staying constant. And consistency is good. That's a good thing. All right, so we have that. And so now we just have to graph it out. So again, it doesn't matter, like I said in class, it doesn't matter when we went through this problem underneath the graph, because none of these numbers are negative here for the y values, so it doesn't really matter. So we just keep everything above it. Okay, so -1, +1, open circle there. -2, I'm sorry, we're doing this first table right here. So we're doing it in black. So -1, +1 was an open circle, which said. All right, so -2, 4, -3, 9. So this is right here. 16 is going to go off the table, so graph. So we're going to just keep it going here. So we're not going to graph that one. We're just going to keep it going. Cool. All right, and then it will go on forever because x is less than -1. Goes on forever. All right, for the other one, other table, -1, 2, -1, 2, 0, 2, 1, 2, 2, 2. And then we just go ahead and combine these. Well, not combine them, but connect them. Because it's a constant function, it goes on forever. So we have an arrow in both directions there. So if we're looking at an end behavior or something of that sort, we should be able to figure it out. Domain and range, we should be able to figure that out. All right, and we will take time to go through that later on. All right, so that's questions 1, 2, and 3. The next video, we'll go ahead and do the next ones.